All right, here we go. Sorry to pick back up. New graph here and some new questions. What happens as you approach 5 from the right-hand side? So you can see 1, 2, 3, 4, 5. 5 is where I have this asymptote drawn. So what happens as you approach from the right-hand side? So coming that direction means I follow the actual graph. And what's happening? Well, it's going straight down to negative infinity. So I would write that as the limit as x approaches 5 from the right-hand side is the positives of my function is negative infinity. All right, what happens as I approach from the left? What's the limit as x approaches 5 from the left-hand side of that function? So as I go this direction, right? Where's the graph? Well, I'm following here. As I get closer and closer to 5, I'm approaching a y value of 1, 2, 3, 4. So the limit as x approaches 5 from the left is 4. So the question next says, does this function have a limit at 5? Well, if from the right-hand side, it's going to negative infinity. Left-hand side, it's going to 4. Then no, it does not have a limit. Basically, can you say what that function is doing at 5? No, you can't. It's going to negative infinity in one spot, it's going to 4 in another spot, so you cannot describe what it's doing. So then this says what happens at x equals negative 7. So x equals negative 7 is here. So if we want to think about this one, I'm using a mouse, so I'm sorry, that's not straight. All right, so what happens at negative 7? Well, let's think about what does the function actually equal? What is f of negative 7? F of negative 7 is 6, because I have an actual point here. Negative 7, 6 is the actual point. Down here, this is an open circle, right? We know that's a spot where it doesn't equal. But what is the limit of the function as x approaches negative 7? As it goes from the left-hand side, as I travel, I know that arrow is going that way, but as I travel towards negative 7, my function is consistently at negative 4. If I travel from the right-hand side, there's all this business, but as I start to get closer and closer and closer to negative 7, what y value am I approaching? 4. So the limit of the function as x approaches negative 7 is negative 4. All right, how about what is the limit as x approaches negative 3? So negative 3 we can see here. I find it helpful to draw, some kind of line. Man, that's crooked. That's offensively crooked, I'm sorry. The limit as x approaches 3. So we think about what's happening from the left. Okay, as I go towards negative 3 from the left, I'm at negative 4. From the right, I travel towards an x value of negative 3, and I'm still going to negative 4. So the limit of the function as x approaches negative 3 is negative 4. And then what's the limit as x approaches 0? What is the limit of the function as x approaches 0? So x is 0 here on the y-axis. All right, so I'm going towards the y-axis. From the left-hand side, traveling up, going towards 2. From the right-hand side, traveling down, going towards 2. They're doing the same thing. And hey, look, it actually equals 2. So the limit at 0 is 2. So interesting to note, over here at negative 7, from the left, from the right, they're going to the same thing. So there was a limit, and it was negative 4, even though there was a hole there. Here, there was no hole. There's an actual value, and that value is the answer. So there was no difference in a limit perspective from there being a hole or not a hole, because the function is approaching that value from both sides. Just like with our n-gon problem, right? In the very beginning, so close to being a circle that it's close enough. Who really cares? It's basically a circle, right? If you increase those sides, that's exactly what's happening here with the limit. Whether it's a, open circle here or a closed-in dot, it's getting so close to that value that that is what a limit is saying. All right. Next up, so if we were in class together, I would show you how to construct a table, but it is not worth doing over virtually here. So I want you to look at these tables that I've generated, and I want to show you how you can look at a table just like you can look at a graph. So we have our function here. We have, feel free, if you have a graphing calculator, feel free to put that in your y equals and then to look at the table, and you could find this. But what I have here are the values for f of x. F of x, is the same as y. So this says, what is the limit as x approaches 1? So you can see my x's are getting closer and closer and closer to 1, closer and closer and closer to 1. So picture, like we would do on a graph, picture approaching 1 from the left, approaching 1 from the right. Now, at the actual value of 1, there's an error. Why? Because that denominator would be 0. But can I see that these values are consistently going towards a number from the left and from the right? These numbers are getting a little bit bigger and bigger and bigger. These numbers are getting a little bit smaller and smaller and smaller. What are those numbers all going towards? 4. So the limit of the function as x approaches 1 is 4. All right, I can see the same thing here. So I have the function x squared over sine x. If I generate this table in radians in my calculator, and I look at what is happening as x approaches 0. So what is happening going towards 0 from the left, going towards 0 from the right. Remember, they have to be doing the same thing to have an actual limit. These values are getting technically a little bit bigger and bigger and bigger, a little bit smaller and smaller and smaller. Can I say what they're going towards? Yeah, I can. That's 0 right there. So the limit of the function as x approaches 0 is 0. All right, we skipped an example. That's why this says 6. It says use each graph to find the indicated limit. So looking at our graph, this looks like a piecewise function. It says, what's the limit of the function as x approaches 0? If there is no plus or minus, it means look at both. So I go towards 0. I know that arrow is going that way, but I want to talk about x going towards 0. Towards 0 from the left, towards 0 from the right. What is the y value they're going to? It is also 0. So the limit is 0. And how about this? What's the limit of the function as x goes to infinity? Infinitely bigger and bigger and bigger. As x gets bigger and bigger and bigger, what's this going to do? It's going to go really, really close to 0. Is it going to get there? No, it's not. It looks like that is a rational function or an exponential decay that would have an asymptote on 0, but it's going to get really, really infinitely close. All right, let's look at a step function. So it says use the graph again to find the limit. Letter A. What's the limit of the function as x approaches -1 from the negative side? -1 from the negative side. All right, let's do a little color coding this time. I'll see if I can draw straighter. All right, so let's focus on, oh, that's awful. Sorry. All right, that's as close to -1 as I can get. So -1 from the negative side, from the left-hand side. So I pick up the function from the left-hand side, and I am at a y value of -2. So the limit of that function as I approach Negative 1 from the negative side, from the left-hand side, is negative 2. How about the limit of the function as x approaches negative 1 from the positive side? From the positive side, okay, there's a lot of stuff happening, but I just kind of travel the steps, boom, boom, boom. And as I get really, really close to negative 1, I'm on this bar here, really, really close. I am at a y value of negative 1. So the limit from the right-hand limit is negative 1. So what's the limit of the function as x approaches negative 1? Well, if it does different things from the left and the right, then the limit does not exist. And what's the limit of the function as x approaches 2.5? So those were all questions. A through C were all questions about negative 1, looking at from the left, from the right overall. Letter D just says, what's the limit of the function as x approaches 2.5? All right. 2.5. Let's do another not straight line. I hope you're laughing at me at home. All right, as x approaches 2.5, what's the function doing? I look from the left, from the right. From the left, getting really close to 2.5, it's at 1. From the right, really close to 2.5, it's at 1. So the overall limit is 1. Yay. We can also actually graph functions to find a limit. We're going to jump to letter B because I'm going to run out of time on my recording here. So we have a piecewise function. Says f of x is x if x is less than 0. F of x is cosine of x if x is greater than 0. All right, so this is y equals x is what that means. So y equals x is a little boop. I'm going to need an open circle here because it's only true for x is less than 0. And y equals x is where every y equals the x, right? Some plotting points, -1, -1, -2, -2. I'll draw another real crooked line for you. All right, and then we have cosine of x. Here's a little review. Amplitude is 1, period is 2 pi. So I would count by 2 pi over 4, which is pi over 2. And pi over 2, 3.14 cut in half is like 1.57. So counting by like 1.5. All right, so cosine of 0 is 1. I go 1.5-ish, and I'm at 0. Another 1.5-ish, and I'm down at -1. 1.5, and I'm back at 0. 1.5, and I'm back up +1. And it says that this is true for x's that are greater than or equal to 0. We know that cosine can keep going. I could keep drawing that, right? Forever, but only true for x is greater than or equal to 0. So I don't continue it to the left. So anyway, there's my graph, and it says use that graph to find the limit as x approaches 0. If it doesn't tell me which side to come from, then I'm looking at both sides. From the left, it's going to 0 on my line. From the right, it's following cosine up to 1. 0 and 1 do not match up, so the limit does not exist. Complicated topic, I think, but in actuality, like what you're doing is actually a pretty quick process, right? When you're looking at a graph here, your answers are quick. What you need to make sure you take the time to do is wrap your brain around the concept, okay? So you're going to have a chance to do that on the 11-1 homework, which is online on Pearson again. Make sure that you are working on those questions till you get them right. Again, they should be pretty quick answers. Make sure that you're thinking about them and reach out if you need any help. Thanks.